Question 7. Financial maths. Now welcome to real maths. Well, on question 7, let's do 7.1. How many years will it take for an article to depreciate to half its value according to the reducing balance method at 7% per annum? Well, what you need to know, the key terms: half its value, reducing balance, and what else? Depreciate, right? It's depreciating, it's not increasing. So now we use this formula. A is called P1 minus I to the power N. Alright? And you are not given the value of P. Neither are we given the value of A. But what are we told? Half. So A is half of P. So A is half of P, or P over 2. Now from there, now we put A on our formula, which is P over 2. Then we put P over 2 is called P1 minus, how about our I? 0.07, 0.07 to the power N. Now we use this formula because it's depreciating. That's why it's got a negative. And also reducing balance. It's a compound formula, right? Now let's work it from here. Now this is like half P. Half P is called P1 minus 0.07 to the power N. Right? Now these P's, they cancel each other, right? If a P is on the other side, the other one on the other side, so they cancel each other. So these P's, they go. Now we remain with half. It's called, now this one, 0.93, right? To the power N. Now this is an exponential function. Now to solve for N, we have to apply logarithms. Alright, now we apply logarithm both sides. So log half is called N log 0.93. Alright, now to get N, we divide all the sides by log 0.93 log 0.93. Now this goes like this. So N is what? N is called log half all over log 0.93, right? Okay, let's try it here. So N is called log half over log 0.93. Now you can punch in your calculator. What do you get?
9.555.
That's it. That's it. So we're going to get 9.551. Okay, let's just leave it to two decimal places. Alright, so our N is 9.55. Yes, that's it. Don't leave it, eh? Yes. Alright. So we are done with this one. Clear?
Do we not have to? Okay, there when it says 9.55 in the whole thing, aren't we is it wrong if we like take 0, all that, because we already know that it's 9 years, and then multiply it by 12, because then it becomes different. It becomes 7 months instead of 5. So I want to know if.
Or like 9.55 years.
Yes, and then you take 0.55 plus the whole thing that follows, and then you times it times 12. It becomes a different thing. So I want to know if we're supposed to do that.
But for this one, there was no need to do that. Sometimes if the question just say how many years or how long, you don't need to express. Unless if it is specifically say express in months, then this one you have to times by 12. But if it's just years, then 9.55 years done. It's fine. Alright.
Sorry. isn't it here we calculating the using the reducing balance method?
Yes.
So how can you tell which formula to use, since we're given 6 different formulas for financial maths?
For the other 6 that you're talking about, I'm not so sure about them. But now for this one, remember there's a straight line and then there's reducing balance. Straight line, you are saying the value is depreciated by the same amount, right, throughout. Reducing balance is not the same amount. Like reducing balance, we are reducing from the balance or the amount that we are given with a certain percentage. Like maybe here we're going to reduce by 7% every year on the balance, right? Not on the cost. So whenever you're told that reducing balance, you need to use this formula because it's for discount, so to speak. But if it's a straight line method, you need to use what? This formula. For straight line, you use A is called P1 minus I. If it was a straight line, you're going to use this. Reducing balance, you're going to use this. But now, how do we know whether we're going to use this formula compared to the other ones that you have said? Remember the other ones, some of them they are used on an annuity. This is not an annuity. We are just looking at present value and future value. So we use this is present value, this is future value, so to speak, right? So that's the formula that we use. We don't use for annuity, we don't use for sinking funds. Of course, we are given those formulas, like only formula, but we don't use them. All right. The other for negative is discount. For plus, which means it's what? Yeah, it's increasing. The other one is discount, the other one is increasing. This one is discount, that's why they say depreciation. Remember, depreciation is going down. Is it clear?
Yes.
So always when reducing balance, use this one. For straight line method, use that one. So now let's go to the second question. Right. We are told that there was 2 friends, right? They received an amount of 6,000 to invest for a period of 5 years. So this is the amount of money, 6,000 to invest, right? So this is sort of a present value. For how long? For 5 years. So N is called 5. All right? And then they invest the amount of money as follows. We are given 2 people. There is Rajesh and Tandi. Now, we are told now, this is how they, after they've been given money for 5 years, this is how they invested. Now, Rajesh invested 8.5% per annum, simple interest. So this one is simple interest. Let me just say SI. And then 8.5% per annum, 8.5%. Then also, we are told that at the end of each 5 years, he will receive a bonus of exactly 5% of the principal. So bonus 5% of the principal. Now this is Radesh first of all. Now let's go to Tandi's condition. He's going to invest it at 8% per annum, compounded quarterly. Okay? Quarterly compounded. So M is what? 4. The number of times interest is compounded. It's quarterly, so it's 4, right? Mm-hmm. Now, we are told who will have the bigger investment after 5 years. Right? Who will be having bigger investment after 5 years. So what are we looking for here? We are looking for future value. Alright? So now, let's start with Radesh first. Now, the working is as follows. He's going to invest 6,000, but let's use the formula first. The simple interest formula, right? Simple interest formula. Because the amount of money is going up, it's not decreasing. So we're going to use A is equal to P1 plus. Alright? So now, what is our A? That's the one that we're going to look for. So A is called What is P? P now is 6,000. 1 plus, what is our I? 0.085 times N, 5 years. Right? What is the answer there? Sorry?
8,500.
Yes, that's it. 8,550. Now, but remember, this is the amount of money that is going to get after investing 6,000. But remember, he has got a what? A bonus. So now, but what is the bonus? 5% of the? Yes. So bonus also is called 0.05 times 6,000, giving you what? 300. Now, so by the end of the period, she's going to get how much total? 8,850. That's it. So this plus this, giving you that. That is what she's going to get by the end of the 5 years. Alright? Remember, the question is saying, who will have a bigger investment? So now let's go to Tandy. Alright. Remember, Tandy is invested at a compound interest, alright, at 8%. So now we use the compound interest formula again. So Tandy, now we say A is equal to P1 plus I to the power N. So now we're looking for the future value. So A is P, 6,000. 1 plus, what is our I? 0.08 to the power N. Punch in your calculator. What are we going to get? Alright. But there's something there. Have you noticed? Now, our I interest is being compounded how many times?
4 times.
4 times. So which means our I is going to be divided by 4. Alright. And how about our N? That's it. So N is going to be 4 times 5. Alright. So this is going to give you 20. And 0.08 over 4.
0.02.
So
6,000.
6,000.
1 plus 0.02.
0.0.
Square root of an exponent of 20.
Yes. So what is the total figure? 8,915. Yes. 8,915.68. Now, this is very important. Make a distinction like this. But then from there, remember the question says, who will have a bigger investment after 5 years? Justify your answer with the appropriate calculation. So, we have done the calculations. What is the answer now? Tandy is going to receive bigger investment. Alright. Now, justification, the answer proves. This 8,915 against 8,850. Clear?
Yes.
So this is question 7.2. Right? Okay. Let me erase it and then we do 7.3. You need to always keep in mind, when you are working with financial maths, write all the information that are given down. That's the principle. Write it down. Okay. Now let's look at that one. Nikki opened the savings account for with a single deposit of 1,000 on 1 April 2011. She then makes 18 months deposit of 700 at the end of every month. The first payment is made on 30 April 2011, and the last payment on 30 September 2012. The account earns interest at 15% per annum, compounded monthly. All right. So now, let's have this. We are going to have the one for single deposit. All right. And the other one, when you are making regular payments every time for a given interval of time, we call it annuity. So we're going single deposit plus annuity. But remember, we're looking at, we say determine the amount that should be in your savings account immediately after a last deposit is made. So we are looking at future value, all right? Because she's making payments so that she will use it. It's a future value. So now let's look at single deposit first, and then this annuity for 700 Rand every month. But we are told that it is 18 months, all right? So our N is 18. Now, as for our I, remember I told that the account earns interest at 15% per annum, but compounded monthly. Please keep note of those. All right. So now our I is going to be 0.15 all over 12. All right. That's it. So now let's punch in our formulas. Now for the single deposit, the initial deposit that was made, like that 1,000 Rand. So we have to say 1,000. We have to use the simple discount formula, or single discount formula, not annuity. We have to separate between this and this. Now that's where it comes to your question to say which formula do we need to think when we are doing this. Now as for single deposit, we use A is equal to P1 plus I to the power N. Alright? This is single deposit. Now for annuity, we use the feature value. That's it exactly. So we have got X, which represents the annuity. Let me just check on the formula. You can also do the same in the exam. So it's X 1 plus I to the power N minus 1 all over I. Right. So now let's come here. Remember, we're looking for the future value. Now for this single deposit. So we're going to say it's called our P. How much is it? 1,000. 1 plus our I 0.15 over 12. Right. And our N 80. Right. That's it. So now, and then we also incorporate this, the one for the annuity. X means regular payment, or the amount of money that is being paid every time, which is our 700 that is paid at the end of every month. And then big bracket 1 plus, what is our I? 0 over to the power 18 minus 1 all over 0.15 over 12. Alright. If you punch in your calculator for the first one, you're going to get 1250.58, right? You can just quickly round off to 2 decimal places, right? And then for this one, what are you going to get? 14. All right. Are you getting the same answer?
175.40.
Yes. Okay. You can work them separately, step by step. But when you punch exactly in your calculator, you should get this is the correct answer. Alright. Now, this 1250.58 is for this single deposit of 1,000, right? That was made at the beginning of April. Now, this annuity of 700 rand every month. Now we are going to get 14,032. Then you add the 2 to get the total amount of money or the future value that you're going to have. Any question?
I have a question. I wanted to find out, like, also below on the run for X, do you have to put 12? Is it necessary to put yes there?
On X?
There on I.
On I?
Yes.
Yes. Yes, you put 12. Well, the formula on every I, when you are told that interest is compounded maybe less than or more than once a year, wherever there's I, you divide by? No, divided by M, or number of times interest is, in this instance, 12. So wherever there's I, you divide by 12. Right? And wherever there's N, you multiply by, if it's yearly. But in this instance, it's monthly, so it's, alright? Because this one, you're going to say 18 over 12 times 12. Those 12 cancel each other. You remain with 18.
So instead of breaking the two, single deposit and annuity, is there any formula that you can use to calculate it once?
You can. Because remember, the other 1,000 is just a once-off. We paid 1,000 by the beginning, so it's going to accumulate after 18 months. You want to see how much is it. And then that 700 was paid like every month, so you cannot combine them. Separate them, and then you really understand. You do this. Here, even if you do this, you get some marks for this. And here also on annuity, you get some marks for this. So it's very important to separate the two. It's very, very important to separate the two. But if you understood on the annuity and which formula do we need to use, and on the single deposit, which formula do we need to use, then that's it. Alright, so the total there will be 1528.91. Done. So that is the amount that should be in your savings account immediately after the last deposit is made. Is it clear? Now let's do question 8. Alright, if you notice on question 8, it talks of f prime x. It means derivative. Alright, so now it says determine f prime x, or first the derivative of f of x. Now check, it says from first principles. So if you don't use first principles, you're not answering the question. Okay, so in the examination, make sure you don't create your own question. Follow the question that you're given. Now it says that f of x is called minus 4x squared. Alright, now from the first principles, now using the first principles is the one that we say f prime x is called limit as h approaches 0 of now f of x plus h minus f of x all over h, like this. Your limit should not be before the equal sign. No, it's wrong. If you leave the limit, it's wrong again. So write it properly as it is. Alright, don't leave this one, don't put it on this other side. It should be exactly as it is. Now let's look for f of x plus h. Let's just do those steps one by one. Now f of x plus h, we go there. It's minus 4. Wherever there is x, we are putting x plus h. That's what it means. So we are going to say minus 4x plus h squared. Alright, now we're going to have minus 4x plus h, x plus h. minus 4. Now, expand it according to the way. X squared plus xh plus xh plus h squared. Now, minus 4 x squared plus 2xh h squared. Alright, and then putting everything like minus 4 inside, opening the bracket, we're going to get minus 4 x squared minus 8xh minus 4h squared. Alright, so now we got f of x plus h. Now let's just input it here, and then f of x is given there, and then we divide everything by h. Right, so let's turn it there. Remember, so first derivative is gonna be, alright, limit as h approaches 0. Now, what do we have? Minus 4x squared. Minus 4x squared minus 8xh minus 4h squared plus 4x. Now, okay, that's it. So we have got f of x is there, so minus 4x squared, right? So it's going to be minus 4x squared, right, over h. Now, going with it again, it's going to be is h 0 minus 4x squared minus 8xh minus 4h squared plus 4x squared all over h. Alright, so now the limit is h approaches 0. Now this one goes, alright? Yes. And then we are going to remain with minus 8xh minus 4h squared. Now this is all over h, right? Now we're going to have limit as h approaches 0. Now let's factor out h. Minus 8x minus 4h over h. Now we're going to get limit as h approaches 0 minus 8x minus 4h. This goes, eh? Then we remain with this. Now, but remember it says as h approaches 0. So, as h approaches 0 here, this will become 0, isn't it? Yes. So we're going to remain with, that is what? Using the first principles. Alright? If you just say minus 8x using another method, that one, you don't get a number. So use the first principles. Alright? So those are the first principles. Any question?
So let's just say you want to check if your answer is correct.
Yes.
You can use the derivative formula.
Yes. But to answer that question, you need
The first principles.
yes. So if you just use that derivative, you are creating your own, and then you answer it. Yes.
I want to know whether negative 4h when I didn't see that part calculated. Like it's negative 8x minus 4h here.
Yes.
Yes.
We are saying like as h approaches 0, remember that's what it says. So as h approaches 0, what is going to happen to this whole thing?
It becomes positive. I'm not sure.
Okay. Minus 4 times 0. What is the answer?
0.
So it becomes minus 8x plus 0, which is nothing.
Okay.
Alright. Because it's as h approaches 0, that's how you get it. Clear? So we can move on. Now let's do 8.21. Alright. Now 8.21. Now it says there, evaluate dy over dx if y is called 3 over 2x minus x squared over 2. Now this is where you use the rules of derivatives. Now that rule which says if y is called x to the power n, then dy over dx is called nx n minus 1. Alright? So now we want to apply that. Now if you look intently on this one, it has got x underneath, but we can bring it to our level, so to speak. Whenever you're dealing with this, bring them to your level or express them to the way that you understand, so that you can be able to apply that rule. Alright? So now we can say 3 over 2 x to the power minus 1. Alright? And then minus x squared over 2. Then from here, remember this is, now from here now we apply, this is still y, and then when you are saying dy over dx, now is where now we'll be saying, remember that rule, so it's minus 1, 3 over 2 x to the power minus 1 minus 1. Alright? Minus now 2 x over 2 to the power 2 minus 1. Okay, now this one will becomes negative 3 over 2 x to the power negative 2. Now this one, this goes and this goes, so it becomes minus x to the power 1. Right? Now by the end of the day we have got it's called minus 3 over 2. Now we bring back that x down. Right? When it goes down, it's no longer negative, it's positive. Yes, minus x.